Okay, hopefully you finished that quiz, and we are going to go into the next part of this lesson. Is dividing exponents. It's actually in your book. It's Exponent 3. The name sounds a little bit different, but it's still the same thing. You're trying to divide the exponents. Some of you may actually ask, what happened to Exponent 2? We're going to do the Exponent 2 as I think it's on Wednesday or on Thursday. That is actually the how we actually combine everything together. So I think we should do the division first, because last time we did the multiplication, it's only reasonable to do the division. So it's actually quite simple. It's a bit like multiplication. If you remember what multiplication was about, just write that out. And so I said, well, if I have the same base, x to the power of 3 times x to the power of 2, the multiplication basically said if you're multiplying them, you're going to add these two. So you can add the exponents together, so long as they have the same base. Alright, so some of you possibly can guess what's going on with division, because I used that operation already. So division, as you may guess, is going to be subtract. But I'll show you why. I will show you why though. So let's say I have x to the power 5. Remember that x to the power 5, that means I'm going to multiply x 1 time, 2 time, 3 time, 4 time, 5 times. So I should have 5 of those x over there. This whole thing is going to divide by x to the power 3. That means I have 3 copies of that. Now, if you treat this like numbers, all of these are numbers, you should know that each of these individual x, I should be able to cross them out. X divided by x is 1. X divided by x is 1. And x divided by x is 1. Therefore, after that, simplification, or we can just, canceling things out, we ended up with only 2x on top. Okay, so the answer is going to be equal to, can I just use blue? X squared. Alright? I'm going to do this with the a as well. A to the power of 6, that means there's 6 copies of that. 1, 2, 3, 4, 5, 6. I'm going to divide by just 1a at the bottom. So one of these get crossed out, so I'm going to count how many a I have. 1, 2, 3, 4, 5. A to the power of 5. Last one. Y to the power of 4. 1, 2, 3, 4. Over 1, 2, 3. So 3 of them will cancel out. This 3 and that 3 will get cancelled out. So my final answer for that is just y. Now, if we look at this, as I said, some of you may be able to guess in the beginning what happened if we're going to do the division. X to the power 5 divided by x to the power 3 is x 5 minus 3. Therefore, we have x to the power of 2. So this agrees with whatever we did earlier. So a to the power of 6 divided by a on its own, it means it's just 1. Oh, I'm sorry. Subtract 1. So it's a to the power of 5. For this bit, y to the power of 4 and y to the power of 3. So y to the power of 4 minus 3, you'll get yourself a y to the power of 1, as I said before. If you notice all of this, that 1 we never weigh that out, this 1 we never really weigh that out. So it's going to be equal to y. So if you remember, multiplication is add, division is just going to be subtract. Okay, so it's really not too bad. It's really not too bad. Not until we are going to put everything together. This chapter is not too bad. So let's give you some examples. Okay. Oh, I should just write the proper definition. The definition for this is if I have x to the power of m over x to the power of n, so long as their base are the same, then I can do m minus n. That's actually a definition. If you go into your book, it's actually on page 384. They will actually give you the definition. So let's show you some examples. And so let's say I have 2 to the power of 6 over 2 to the power of 4. It's still the same idea. The base, we check the base. If the base are the same, what's the base over here? 2. What's the base over there? 2. So they have the same base. So I can simply do this 6 minus 4. Then I'll get 2 to the power of 2, which is just going to be 4. Alright? Do another simple one. 10 to the power of 9 over 10 to the power of just, let's just do a 6. Okay, so 10 to the power of 9 minus 6, you're going to get yourself a 10 to the power of 3. Then that's just going to be 1,000. 3 zeros. So if the base are the same, they're not too bad. And of course, we normally don't stay with the numbers. Sometimes they may have numbers in conjunction with like variables, so we can do that. So for example, I'll have x to the power of a over x to the power of 6. Okay, this looks very confusing. There's some variables over there, but it's still the same base. They still have the same base, so I can do x to the power of a minus 6. That's all you have to do. There's nothing you can do. Learn where to stop. Let's make one that's a little bit more difficult. So x to the power of m plus 1 divided by x. Do we have the same base? Yes. So x to the power of m plus 1, that's the exponents on top. We are going to subtract by 1 because that is 1 itself. So you ended up with x to the power of m. So add or subtract is still going to apply whether it's going to be exponents or not. Okay, and another one. Some of these can be a little bit more confusing. They may actually have 4 as an example. X to the power of 2, y to the power of 10, and let's create another variable. Why not? Over y to the power of 2. Let's put 2 in front. Alright, I think this is a good example. So, in this example, you have to be careful about a couple of things. You have to decide on what you have to do. Obviously, if we're looking at the base, we know that we only have the y having the same base. So the x and the z, we are not going to touch it. We cannot do anything about it. We cannot do any subtraction, and I cannot multiply them. And then the other thing you may have to be careful about, some students always skip this bit, is this 4 and 2. They are just on its own. 4 divided by 2, you should be able to do it. Just don't skip that step. So I'm going to do this green bit first. 4 divided by 2 is going to be 2. X, nothing I can do about it. Y, 10 minus 2 is 8. Z is going to be 4. Okay, it's going to be 4. So this kind of questions, just make sure you check all the base, you check all these coefficients, and see if we can do something about the division. Let's make another one that is even more difficult. Let's do a 2 over here. Let's do a 6. I'm gonna have x to the power of 2, x to the power of 5, y to the power of 10, just put a z over there, okay? So in this scenario, we are going to check the base. X and x are the same, y and z, there's nothing. The coefficient, this 2 and 6, hopefully you can simplify that. So 2 and 6 should turn into 1/3. So if we can simplify that, we're going to do that. So 1/3. So we did the green bit first. So this x, okay, x is going to be 2 minus 5. 2 minus 5 is going to be a negative 3. The y cannot do anything about that. So that stays wherever it was. Z is going to stay. Now some of you may just, okay, we are done. We did all of this. It's not done, is it? If you remember what we did in the beginning of this lesson, you should know that this item is not right. The reason why it's not right is because we have a negative exponent. So that's what I meant earlier. When all of this combined, you just have to be very careful about that. So this x to the power 3 has to go down. So 1 is going to stay. In fact, that 1 times y to the power of 10, we normally don't write that, but for the time being, I'm just still going to do that. Y to the power of 10, 3, x is going to come down because of the negative exponents, and z is going to stay. Now, some of you may ask, does it really matter where you put the x? It shouldn't matter too much because you're multiplying things. I would normally keep that as the alphabetical order, x, y, z, so x go first. If I really want to tidy up this answer, I'll have that, because I normally shouldn't have to write that 1. Okay? So that would be the nicest way to write the answer. That 1 is not really contributing anything. Let's see what else I can do. I should give you one more example. Okay, I'll do one more example. So let's make this ultra difficult. We'll have a negative x, x to the power of 3, z to the power of 7, 2x to the power of, let's make it big, 10, yz. Let's really make it difficult. So this will possibly be the most difficult one you're going to run into. That there are many things going on, and we will just break it into different parts. Okay, when you run into something that's complicated, just break it into the 2 parts. Use your knowledge one at a time. So this negative x and that 2, they go together. Okay, and in the first place, we are just going to find out what goes together. X, 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 they all have the same base, and you may be going like, oh my god, there are like 3 different x's over there, what are we gonna do? Don't worry, we are gonna deal with that. And then we still have a pair of them, z. So there are lots of things that are going to match together, and we are gonna do one thing at one time. So negative x divided by 2 is not too bad. We should be able to get negative 4 right away. So we are going to deal with this x. We're going to deal with this x. If you remember the order of operation, okay, that please excuse my dear Aunt Sally, you remember that multiply 2 numbers go first. So we're going to do this x to the power of 3 and x to the power of 2, the multiplication goes first. And I'm not going to be lazy, I'm just going to write that out. X to the power of 3, x to the power of 2. We are just going to do this first. Multiply them. Okay, so I didn't touch this one just yet, so I better write that over there. And then z, I can deal with this. So it's c to the power of 7. That's going to be just a 1. 6. Okay, the y, I didn't touch it, so put it over there. So I multiply the x on top first, and then I'm going to carry on after this step. So I have a -4. Now I have to deal with the x. Okay, I should use a different color, but yeah, stay with the yellow. Then I can deal with the x. So x is going to be 5 minus 10, -5. Z is nothing anymore. And y. Alright. I'll give you 2 seconds to think about it. Not done. Exactly. Very good. So we have a -5. That -5 is going to be, it's going to bother me. I cannot have a negative exponent. You may say, well, you have a -4 over there. Why are you not caring about it? It's not exponent, isn't it? So we only deal with the exponents. So -4 is going to stay. Z to the power of 6 is going to stay. This is going to get a swap. There you go. So is it complicated? I normally don't think so. Normally when I do this kind of question, I can actually do this in my head in one step. But in the beginning, you may want to weigh all of this out just to make sure you understand the process. Alright. This is it. Okay, the division is divide. Is subtract. Multiplication is add. So it's a combination of that. And for this, I'm not going to have a quiz just yet. Possibly we are just going to work on some classwork for the rest of this class and homework. And when we come back again, which is on Thursday, we are going to talk about another expression. And then we are going to put everything together. And hopefully this is helpful for all of you. Okay, bye for now.